In today's lesson, we are going to start Unit 5 by talking about keywords null, this, as well as topics such as aliases and equals. All of these topics we have grazed over before, but today we're going to go into them much deeper. First, let's begin with the null reference. An object reference variable stores the address of an object, and if this variable does not point to an object, then we call this a null reference. If we were to say, for example, in this code sequence, string name, well, right now, name is ready to point to something, but there's nothing there. And if I tried to do name.length, this would give me a null pointer exception. It would not tell me that the answer is 0. It would just say that there is a null pointer because it's literally pointing to nothing. Now, if I had declared name to equal quote, quote, then this would point to an empty string, which would have a length of 0. So without doing any instantiation here, this is a null pointer. Now we can test for a null pointer by checking to see if the reference variable equals null. And if it does equal null, then we can go ahead and we can handle that. And if it's not equal to null, then we can go ahead and do whatever we need to do. This works for any object and is especially useful when you are working with a partially filled array. So at times you will keep a counter to tell you how many values are in the array. Another thing that you can do is to test if the entry is equal to null before you try and do whatever action you're trying to do. The next keyword we're going to talk about is this, and we have used the word this many times. A common example where we see it being used is when we are working within methods of a class that operate on instance variables. So let's say, for example, I created a new bank account object and then I deposited money into this bank account. Inside of my bank account method, I can refer to the balance instance variable as balance, or I can call it this.balance. And the keyword this essentially refers to whichever object called the method. So in this case, since the object my account called the method, then my account is called this. If another object calls the deposit method, then this refers to that object. So whatever comes before the dot is called this inside the method. All right, now alias is one of those terms that a lot of times students have a hard time understanding. So let's say, for example, I were to compare primitive data types and objects. So if I were to say num1 equals 5, that is going to create a fixed amount of space in memory, label it as num1, and put the value of 5 there. If I created another variable num2, another fixed amount of memory, and put the value 12 here. Now, if I say num2 equals num1, this is going to replace the value in num2 with the value that is in num1. These two have no connection whatsoever. All that we did was copy the value over. If I were to say num2++, now num2 is equal to 6. Notice that num1 did not change at all. Now, in contrast to that, when I'm working with objects, here when I say account1 and I am creating a new bank account, this is going to create a new bank account with the details of Dana, 1200, and 111. And then when I create another account, so this one will be called account 2, and this will point to another bank account object with the name Nichols, balance 1500, PIN 2222. All right, so now this line of code, when I say account 2 equals account 1, that means that account 2 now points to what account 1 equals. And so now I have two variables referencing one object. And this guy right here is now going to go to garbage collection. Sorry, Mr. Nichols. This object is no longer accessible. So now when I say account2.deposit, account 2 points here, deposit 500, now Dana has 1700. Account 1.withdraw 100, account 1 points here, withdraw 100, now Dana has 1600. So we say that account 1 and account 2 are aliases of each other. And the reason why we call them aliases is because on the surface, when you look at the code, it looks like you are interacting with two different objects. However, because they actually point to the same object, you are really just working with one bank account. So when I ask for the value of the balance of account 1 and account 2, since account 1 and account 2 both refer to the same account, they both have the same value. So in this case, I have made 2 reference variables. I have made 2 objects. And at the end of the code sequence, only one object is accessible. Now, if we continue on with our aliases discussion, in the beginning, account 1 and account 2 refer to 2 different objects. However, when I have this line of code, they both refer to the same object. And so any changes made to one reference affect both account 1 and account 2 because they are in fact the same object. Now, we are used to using the equals equals to compare primitive values. And when we are working with our primitive values, this will check if the value of each of those is the same. However, when we are working with objects, the equals equals works different. The equals equals checks if 2 variables reference the same object, meaning they have the same address. It is not the same as if checking if the 2 objects are equal. So if I were to go ahead and make 2 accounts, so account 1 and account 2, and notice that this is a different bank account constructor, so that constructor must be overloaded. And the first one has the name of Dana and the balance of 2,000. And the second one also has the name of Dana and the balance of 2,000. And then I create another reference variable that refers to the same object that account 2 refers to. So now I have account 3 that is also pointing here. So when I check to see if account 1 and account 2 have the same address, well, they don't because they're physically pointing to different places. So this would print false. When I check if account 3 and account 2 have the same address, well, this would print true because they are both pointing to the same object. So on the surface level, a lot of people make a mistake here thinking that because the values stored in the objects are the same, then the references are the same. And that is false. Checking if the references are equal just checks if they point to the same place in memory. If we want to actually check the contents, we need to use an equals method. So let's come back to that. Our equals method, we've seen this quite a bit with our string class. So the string class has a built-in equals method, and it returns true or false if the string variables contain the same string or the same sequence of characters. And we call it by doing name1.equals name2. Well, we can also create an equals method for our own classes, and we've done this so far. We're just revisiting this concept. And in order to do that, you have to first decide what it means for 2 of our objects to be equal, because it's quite possible you have 6, 8, 10 instance variables, and maybe they don't all have to be equal in order for the objects to be considered equal. And that's something that you, the programmer, has to decide upon. So the rules for our equals method, and these are rules that you have to follow, you do not have flexibility here, is that there is one parameter that matches the object type that is calling the method, must return a Boolean, and does not print anything. Also, your class code can only have one equals method. So in this example here, we wanted to check for equality on balance and bank account name. Now, it's important to remember that since balance is a primitive data type, we can check for equality using an equals equals. And since the name is a string, we check for equality using the string method .equals. And so what this code is saying is if the balance is equal and the name is equal, return true. Otherwise, return false. The last topic we're going to talk about today is passing an object as a parameter. So remember that when an object is passed as a parameter, changes that are made to that object are going to affect the object state because we are passing the address where the object is stored in memory. It's kind of like giving somebody your house key. If you lend somebody your house key and you come home, if they were in your house either cleaning or making a mess, whatever they did, you would see when you get home because the key that you gave them literally opened your front door. And that's like what's happening when we pass an object as a parameter. To emphasize this, we are going to look at a new method that has been added to our bank account class. And this method is called steal money. And this method accepts a bank account object, which we will call other account. And what happens is that the object that called the method, so this, is going to deposit the amount of money in the other account, and then it's going to set the other account's balance to 0. In effect, taking all of the money out of this account and putting it into the one that called it. So let's see how this would look when it's being called. All right, so if I had two different bank accounts, just like we made before, if I had my account 1 and my account 2, and then I said I wanted to do account 1.stealMoney. Okay, so up here I have the code for this method, and account 1 is the calling object. So this is what we are going to refer to as this, and it is stealing money of account 2, which will be referred to as other account. So when I come inside the method makes a local variable called other account, and it is pointing to account 2. So right now I have this local variable called other account, and it is copied the reference of account 2 and it's pointing here. And I'm inside the method, and according to the method, this, which is account 1, is going to deposit other account's balance. So I'm going to get the balance of $1,500. I'm going to add it to $1,200, and now this account 1, has $1,700. Then other account, I'm going to set the balance to 0. So sorry. And so now this balance is 0, and the balance of other account is 0, and the balance of this object that called the method, account 1, is equal to $1,700. I leave the method, and then now when I come out here and I print account 1's balance, $2,700, simple math error. I'm going to print $2,700, and when I print account 2's balance, I'm going to print 0. This local variable that was created for the method is gone. It is deleted. However, the object that it was referring to still exists because it was created before the method was created. And last but not least, we're going to talk about constructors. Constructors are one of those things that for whatever reason, students sometimes have a difficulty understanding why they need them. The purpose of a constructor is to instantiate objects and initialize variables. Very rarely will it ever be empty. That is terrible. We don't want to do that. So if you have an object, an array, or an array list, that's an instance variable, you create the private variable outside of the constructor, and then you instantiate the object by calling its constructor inside the constructor. All right, let's look at an example of this. So here I have another class called Account Manager, and this class is going to have an array of bank account objects. It's going to have a static of the number of family members in the family, and then it's going to have a variable that talks about the number of accounts are used. And this is a placeholder because it's possible that maybe not everybody in your family has a bank account yet, but they will at some point. So this accounts manager, the number of family members is going to be passed in as a variable. So note, this is a final variable. It's a constant. It can't be changed once it's been established. So since I established its value in the constructor, now the number of family members is equal to that value and cannot be changed. Next, I go ahead and I create an array that is of the size that was passed in. And this is important because some families have 5 people, some have 10, some have 2. And so when I create my account manager, I can say how many people I want, and then I just make my array as big as I need. And then the number of accounts used so far is 0. And there's a good chance that this method, this class account manager would have a method, for example, called public add account, and it would probably take a bank account object. We'll just call it ACCT, and then here it would say, for example, the name of the array, so family accounts bracket num account used equals account. So this is adding that account to the array. And then we would say num account used plus plus. And this is just an example of how we can use our constructor to set up our account manager. And so that makes everything ready to go. And then now we can go ahead and interact with it later. All right, that is it for today. Thank you.